this one. It'll fix itself in a second. There we go. All right. So hopefully we can get through all these. If not, we'll finish tomorrow before our next worksheet. Okay, so problem A, we started tall sunflowers are dominant to short, while yellow are dominant to orange. We're crossing a plant that is heterozygous for both traits with a plant that is homozygous for height and heterozygous for color. So we have parent 1, heterozygous for both, parent 2, homozygous, dominant, height, heterozygous for color. What are our possible combinations for parent 1?
Capital P, capital
TF.
capital P, lowercase f, lowercase p, uppercase f, and lowercase p, lowercase f.
And so I'm going to go ahead and write those on my Punnett square. And then for parent 2, our combinations.
Uppercase f, uppercase p, lowercase f.
And then those two would just repeat again. So we can just ignore the fact that those are there.
Insha went home because he wasn't feeling good.
Oh.
Athletics messed him up. Rotating. He was not athletic.
All right. So when we cross these two for this box, so big T, big F, big F. These two, we get big T, big F, little f. These two, big T, little t, big F, big F.
Mm-hmm.
And then big T, big F, little f. And in the second row, we have big T, big F, little f. Big T, little f, little f. Big T, big F, little f. And big T, little f, little f. And if we were to repeat this, these two, this row and this row would have been the same, and this row and this row would have been the same. So that's why there's no need. All right, so what possible phenotypes do we see here? All of these have at least one big T. So all of them are going to be red. We don't have any, or not red, tall. We don't have any short plants. So the first combination would be tall and what?
Short. Or tall and yellow.
Tall and yellow. And how many of those do we have? So anything with at least one big T or one big F, we have 1, 2, 3, 4, 5, 6. So we have 6 out of 8. Which reduces to 3 out of 4. And then our other one is tall and orange.
2 out of 8.
For those, we have 2 out of 8, which is 1/4. So to make this into a ratio, we have 3-1. Okay, then it says, a farmer knows that most people prefer tall and yellow flowers. If he plans to grow 100 sunflowers from these 2 parents, how many can be expected to be tall and yellow like he desires?
Yo no sé, señora. Yo no sé.
Don't know. So for me personally, how I would do this is I would use this fraction right here for tall and yellow. So 3/4 and then x over 100. So then you cross multiply and divide. Have y'all done that in math?
Yeah, like in 5th grade.
Yeah. So 3 times 100 is 300. Divided by 4 is 75.
Oh, man. I was doing wrong.
So if he planted 100 flowers, he should expect 75 to be tall and yellow.
And the rest of them were short.
The rest of them would be tall and orange.
I did the wrong one. I put on this one.
I mean, if you want to start over, go for it. I'll just take a picture of that real quick so we can move on before the bars.
I got it on the
Okay. So for problem B, what would our combinations be for our alleles?
Yep. So it'll be E and uppercase E and lowercase. Oh. Yeah.
And then we have the same combinations here.
Mm-hmm. So it'll just be 1 and 1, right? It'll be 1. Do the same thing again?
Like the ratio?
Yeah.
No. We did do a ratio like this on our notes. And we did the notes for dihybrid crosses.
Yep.
So we have big E, T, T, E, E, T, T. E. Right. So that one you do have to fill it in all the way.
0.
Our possible genotypes or phenotypes, my bad, would be free and straight. Free and hitchhikers. I'm going to put HH again for hitchhikers. Attached and straight. And attached and hitchhikers.
Mm-hmm. Yep.
So this first one, I'm gonna highlight this. Free and straight. Free and straight are both dominant, so we need at least one dominant for each type of trait. So ears or thumbs. So here we have 2 dominant for each. 2 and 1, 1 and 2, 1 and 1, 2 and 1, 1 and 1, 1 and 2, 1 and 1, 1 and 1.
Mm-hmm.
So how many? 5, 6, 7, 8, 9. 9 out of 16. Free and hitchhikers, so dominant, at least one dominant for ear, and double recessive for thumb. We have 1, 2, 3. So we have 3 out of 16. Attached and straight. So double recessive for ears, at least one dominant for thumb. 2, 3. 3 out of 16. And then this one, attached and hitchhikers, 1 out of 16. So our ratio would be 9. So remember, this is the one that I told y'all the other day. I think I told y'all. I told most of my classes.
Oh, yeah.
On
There'll
the
be
STAR
one
test, I have been told that every year there's been at least one question over Punnett squares, and it usually pertains to the dihybrid cross and a 9331. And it'll usually ask what set of alleles will make a dihybrid or make a 9331. And that would be both parents are heterozygous for both traits. Okay. And then what are the chances the parent ends up with a child that doesn't look like either of them? So if they're both heterozygous for both traits, they both have at least one dominant. So then they're both going to have free earlobes and straight thumbs. So what's the chances of them having kids that don't have both free earlobes and straight thumbs? Well, we have, this one has free earlobes and hitchhikers. This one has attached earlobes instead of free earlobes, and this one doesn't have either. 7 out of 16.
Oh, I got it.
Because only these ones right here are going to look like them. As far as ears and thumbs. Only those ones will look like them.
It's time to go, man.
Okay, so we'll do these two tomorrow, first thing. when class starts, and then there is a worksheet. That one's going to be a minor grade. So that one you're doing on your own. I mean, I will help if you need help, but we're not going to go over it like this. Thanks.
Oh, you made it.